So again, today our main objective is going through the concept of loop in programming language. So almost every programming language also use the loop control structures. So this is our chapter 5 of the course textbook. We're going to discuss about looping. And this is again programming logic and design course. So in this chapter again, we're going to discuss the advantages of looping, also how to use a loop control variable, and nested loops, also how to avoid common loop mistakes. And the most common loops in almost any programming language is the for loop and also the while loop. We may discuss both of them. I would say the most advantage, one of the major advantages of looping is that we reduce the number of statements we have to write. So for example, if I want to print a statement on my screen 100 times, I don't want to write the print statement 100 times, but rather I'm going to write it once and I'm going to write it in a loop. And I will tell the loop to execute 100 times. So normally we have the counter control loops and we also have the sentinel loop. A counter control loop means we know how many times the loop will execute. So if it's 100 times, I can start the count variable from 0 and I'll end at 99. Or I may start from 1 and end at 100. So I know how many times the loop will execute, which is called a counter control loop. Normally the for loops are counter control loops. Then also we have a loop that we normally use a sentinel value to stop it. So this means we don't know how many times the loop will execute. But let's say I will say that, okay, there will be a condition. Actually, all the loops, for loop, we have to have a condition that the loop will execute up to 100 times. Same thing with the sentinel loop, we're going to have a condition that if I enter the sentinel value, the loop will stop. So which means the first time I enter the sentinel value, the loop will not execute at all, it will stop. I may do something 3 times or 4 times. In this case, I may enter an input 4 or 5 times. And anytime I enter the sentinel value, the loop will stop. So again, those are the main concepts. Looping is about repeating something over and over, repeating a statement over again. Or a task, I would say repeating a task over and over again. So here we say that looping makes computer programming efficient and also worthwhile. In this case, again, we write less statements. If we want to do something over and over, we just have it inside the loop. Also, this is what we mean. We write one set of instructions to operate on multiple or separate set of data. And this will lead us to a less time required for the design and coding. Also fewer errors. The less code we write, most likely we're going to have a few errors. Also shorter time to compile. So the definition for loop, again, is a structure that repeats actions or tasks while some condition continues. Normally in the loop condition, if the condition is true, the loop will keep executing. When the condition is false, the loop will stop. So this is an example of a dual alternative or binary selection structure. So for example, as we said in the flowchart, our diamond symbol here means a condition. So if the condition is true, I will go over, condition is true is yes, then I will do some tasks, then start all over again. So this is the loop. Remember in the selection structure, we have yes to execute some tasks and we keep going down. Or if it's no, maybe we skip the task and we keep going down. But in a loop, we have to repeat something over. So if the condition is true, which is yes, we perform the task and we go over again and we test the condition again. If it's true, we keep performing the task. Now, when the condition is false, that's when, again, we get out of the loop. The false means no. So this is the flowchart for a loop structure. Check a condition. If it's true, which is yes, we execute whatever task, then we come back again to test the condition. If it's true, we execute our task, come back, come back again to check the condition. If it's false, we come out of the loop. So we have a flow chart here. Let's go through this step. We can see where we have the condition, that's where our loop is. So first we have a declarations. This will be declaration of different variables we need for the program. Then we have a function called housekeeping. Maybe this will print some statements, some instructions for us. Then next, we have a condition saying that if we haven't reached EOF stand for end of a file. So let's say we are getting the data from a file. If we haven't reached the end of the file, then we need to do some tasks, maybe get more data from the file until if there's no any value in the file, which means we have reached the end of the file. But the condition said not end of a file. So if we haven't reached the end of the file, that means the condition here is true. So that's yes, we may execute whatever task we have. Then when we reach the end of the file, this condition becomes false, not end of a file, but rather we reach end of the file. So if the condition is false, which is no, we come out of the loop. So again, that's the main concept of a loop. It can be a while loop, for loop, or do while loop, any type of loop. Again, the whole idea is trying to do something over and over again based on the condition given to us. If the condition is false, we come out of the loop. If the condition is true, we keep executing and then go all over again inside the loop. So this is the pseudocode also. We start, we have our declarations of different variables we need. We do our housekeeping. And this is our conditional while not end of a file. Normally, this condition not end of a file, we go with a while loop. While loop. So kind of end of the file is like a sentinel value because we don't know the file may be only 3 items, it may be only 100 items that we have to get from the file. So we don't know, but our sentinel value here means if it's the end of the file. If you reach the end of the file, then we have to come out of the loop. So that's why here in the pseudocode, we are using the word while because we have a loop called the while loop. So while we haven't reached the end of the file, then we do something. The detail loop will execute. Then we go back again, check why not end of the file until we reach the end of the file, which means the while condition here will be false. So if it's false, we come out of the loop. And that will be the end of the job execution, then we stop. So now, when we are using loops, we need variables, or here we call it the control variables. Especially for loop, we have to initialize our counter, which is the control variable. And then if, for example, I want to execute 100 times, I can initialize it from 0, and I'll make sure my condition will be less than 100, which means I'll go up to 99, less than 100. Or I can write less than or equal to 99, which still means I'll go up to 99. Normally, loop is good to use the whole numbers. We shouldn't use the decimal values because decimal values, because of the decimal places or the precisions, we may have a loop that will have infinity because the decimal number of decimal places may change and depend on the type of data we have, data type, like we have long is for int. When it comes to decimal numbers, we have a float, and also we have double when we are doing Java. Double have like 15 precisions, and that's decimal places, and the float have I think somewhere around 7 decimal places. So yeah, we say that as long as the condition remains true, as we said earlier, the statement in the while loop body will execute, whether it's a for loop or while loop, it will execute, which is here as far as not end of a file, the statement inside the while loop, which is the detail loop, will always execute. Until the condition is false, then we come out of the loop, which we can see from the flow chart. Not end of a file is true. Okay, execute the detail loop function. Check again. Not end of a file, true. Execute the detail loop function. Check again. Not end of a file is false. Then come out of the loop and execute end of job function. Stop. So that's what we mean here. As long as the condition remains true, the statement in a while loop body execute. Also, the control number of repetitions. As we said earlier, with for loop, we have loops that we call counter control, which means we know how many times the loop will execute. Most of the time it's for loop. While loop also can be a counter control loop based on the condition we give, but we also can use a sentinel value that can stop the loop at any time based on the value we enter. So here we say the control number of repetition. The loop control variable will, of course, initialize before entering a loop. So if I start from 0, then it will initialize the variable, the counter variable to 0, or 1, you can initialize it to any value. Then when we enter the loop control variable will be tested based on the condition to be tested. We will see this when we implement a loop in a Java programming language, hopefully today, if not today, hopefully next week. So the body of loop must alter the value of loop control variable. One thing also is that first you have a variable to initialize. You initialize the variable, that's where you want to start from. I want to start from 1. Then I may have a condition that while the counter variable is less than 100, which means I have to go up to 99, less than 100, we do something. Then we have to increment the variable, either increment or decrement. Increment means if I start from 0 and I'm going up to 99, then every run I have to increment it. If I don't increment it, I'm going to have infinity loop because the condition will always be true because 0 is always less than 100. So you have to increment it to 2, 3, as every run you execute, increment by 1. Also, we may have a loop whereby we may decrement. So I will initialize my counter to, let's say, 100. And then I will say if the condition is the value is greater than 0, then I'll decrement it. So this means I'll go from 100 all the way to 0. Normally, we do this. For example, if I want to print an item in an array, array will be our next topic. I have the index from 0 to 99. So the first value in the array, the index is 0. And the last, we have 100 items. The last item will be 99. Again, array size can be any size. It can be 10, 5. I'm using an example of 100. So if I want to print the items in the reverse order, then I have to start from 99 and print all the way to 0. Again, we may discuss that one later on. So we already used the term counter. So we said the repetition is controlled by counter because we have to counter variable from 1 to 2 to 3 anytime we increment, or from 9 to 8 to 7 if we are decrement. So the counter is used to create the definite counter control loop. Again, a counter control loop means we know how many times the loop will execute. Then, as we mentioned earlier, the sentinel value normally can be used to create an indefinite loop. This means if I don't enter the sentinel value, the loop will keep executing until I enter the sentinel value, then the loop will stop. And anytime we are creating a loop, we should be very careful because sometimes we may end up having a condition that cannot be met. If the condition cannot be met, then the loop becomes infinity loop. Infinity loop means the loop will execute forever. There's no stopping condition. So a definite loop means the loop executes a predetermined number of times. We know how many times the loop will execute. Then a counter control loop or counted loop the program counts the loop repetitions. And as we said earlier, the loop control variables can be altered by incrementing or decrementing. If you don't do these two, one of these two, then your loop will be infinity. Either we increment the counter, I'm going from 0 to 10. I will increment the counter from every time I do something, I will increment by 1 and 2, 3, up to. And also it depends. Sometimes, let's say, for example, I may have a loop that I want to print an even numbers from 1 to 200. Well, I don't want to write print statement 2, 4, 6, 8. I mean, that's like writing 50 print statement. So I can have inside the loop, and I will initialize the loop to 0. If it's an array, we start from 0. But instead of increment it by 1, I will increment it by 2, which means I want to print 2. So I will print the counter. The counter start from 0, I'll print 0. The next time increment by 2, I'll print 2, I'll print 4. So it depends. You can do anything in a loop. The counter is up to you how you increment it or decrement it. I can increment it by 2, by 3, by 5, anything. It's up to you. So let's see this example using a definite loop with a counter. Here we have a declaration, and here you can see that we declare variable name count. So this means we are using a while loop here. The count will be the loop control variable. So anytime we have a loop control variable, we have to initialize it. Initializing is very important otherwise, because initialize will tell you where we are starting from. So here we initialize it to 0, which means we are starting from 0. Okay, so if I'm starting from 0, I will go to the condition is, so now count is 0 because we initialize the count to 0. So now we are going to check, is count less than 47? Yes, because it's 0. 0 is less than 40. Oh, sorry. Is 0 less than 4? This is a question mark, not a 7. I thought it's 7. So here we say 0 less than 4. Yes. Okay, if it's yes, then we print an output for LO. Then what we do, we increment the counter by 1. If we don't increment the counter, that means the count will be always 0. And 0 will always be less than 4. So when we increment by 1, we go back again to the loop. Now the count is 1. Is 1 less than 4? Yes. We print LO again. Then we increment by 1. It becomes 2 now. Is 2 less than 4? Yes. We print again LO. We increment the count by 1 again. So from 2, we get 3 now. Is 3 less than 4? Yes. We print LO again. Then we increment by 1 to 4. Now we check, is 4 less than 4? No. Then we come out of the loop. Then we print out goodbye. So this loop here allows us to print LO on our screen 4 times. From 0 to 3 is 4 times. But we write the output statement only once, and it's inside the loop with the condition that the loop will execute 4 times. So when the loop executes 4 times, it's going to execute output LO 4 times. So I'm going to wait for a few seconds if any question. Also, we can look at the pseudocode. So again, we start, we declare all the variables we need. In this case, we just want to declare our count, or we say the loop control variable. We declare it as num. Always, as we said earlier, the loop control variables should be a whole number. Don't use the decimal value. So it can be int long as far as it's a whole number. As we said, decimal numbers, because of the decimal places, you may end up having to print something or to do some execution many times because you have a lot of decimal places. Sometimes if it can be infinity. So always we use the whole number. So here we initialize our count variable, which is the loop control variable, to 0, which means we are starting from 0. Now our condition said is count less than 4. Remember, count is 0 now. Excuse me, count is 0. So we check here, 0 less than 4. Yes. So we're going to print LO. Then we increment the count by 1. Then we come and check again. Is 1 less than 4? Yes. So we print hello second time. We increment the counter by 1. So we have 2 now. Is 2 less than 4? Yes. We print hello again. We increment the counter from 2 to 3. Is 3 less than 4? Yes. We print hello again. We increment the counter to 4. Is 4 less than 4? No. Then we come out of the loop. Then we print goodbye. So if we implement this in Java, we are going to print hello 4 times on our screen. Then later we print the goodbye. So here also we are using indefinite loop with a sentinel value. So the previous loop we saw is counter control. We know how many the loop will execute. We are starting from 0 and we say the condition is less than 4. So which means the loop will execute 4 times. But now we don't know how many times the loop will execute here. As we said earlier, the sentinel value will be a special value that if we enter, the loop will stop. So here again, we have a start, we declare some. Now, when you are using a sentinel value, you don't need to declare an initial variable, like the loop control variable to initialize it. No, you don't do that. We don't start from a specific value, because if we know how many times the loop will execute, we start from a specific value and we end at some specific value. We know how many times the loop will execute. But here we are using a sentinel value. So I may enter the value first time and the loop will not work normal. It won't execute at all. I may enter it the second time, the loop will execute only once, then it will stop. Third time, it will execute 2 times. And so how many times the loop will execute, we don't know. So we don't use initialize. We don't initialize the loop control variable here. So here we declare variable name should continue. The data type is string. And we have an output that do you want to continue? You say yes or no. Then we have input should continue. And this will be the loop variable is initialized. But again, they didn't initialize by value that we are starting from a specific value. Here, basically, if you look at the condition, we are saying that it should continue equal to yes. So anytime we have to enter the input always, that's what is here. Do you want to continue, yes or no? So if I say yes, this condition will be true. Should continue equal to y, which means I enter yes, y. If it's true, then we do something. If it's false, which is if we enter n, then we go out of the loop. So the first time, if I enter n or no, then our condition again is false. So which means the loop will not execute at all. Now if I enter yes, the condition is true, then it will execute. So that's again using a sentinel value to control the loop. So this example, your typical execution for a program, which was the example. So will you continue? If you enter yes, it will print hello. Yes, it will print hello. Then when you enter no, it will print goodbye because we come out of the program. So here you can see that if we enter no, the condition here is false. So if the condition is false, we come out of the loop. So understanding the loop in a program's mainline logic. Here they say there are 3 steps that will normally occur in every properly conditioning loop. 3 steps. For especially in a for loop, a while loop, the counter control loop. First, we provide a starting value for the loop. That's counter control loop means we initialize the loop control variable. We again starting value, initialize it. Then when we initialize, let's say we want to print something 20 times. I will start from 0. So first step, I initialize the loop. Then second, I have to test the loop control. So if I initialize it to 0, my next will be is 0. Let's say the variable name is I. So we say I equal to 0. We start from 0. The next we say I is less than 20, which means I'm going to execute 20 times from 0 to 19. 0 to 19. So I'll go up to 90. It's 90 less than 20, yes. When I increment by 1, is 20 less than 20? No, the loop is stopped. So it will execute from 0 to 90, which is 20. So those are the three things we discussed earlier. First thing, we provide a starting value for the variable that will control the loop. Then we have a test condition to test the loop control variable to determine whether the loop will execute. If the condition is true, the loop will execute. If the condition is false, the loop will not execute. Then, of course, we have to alter the loop control variable. Either we increment it or we decrement it. Otherwise, we are going to have, again, infinity loop. Infinity loop, the loop will keep executing for good. So this is another example here, but again, the same concept. Let's look at the loop section. You can see the condition here given. This is a sentinel value. We are saying that if the name is not quit, which means anytime I enter any name or anything, I will do something. Then I'll come and check the condition again. Then if I enter quit, which means the condition here becomes false because the condition said name not, and the lower and the greater sign here means not. So here we say name not quit. So if I enter quit, that means the condition is false because the condition said it's not quit and I enter quit. So it's quit. So in this case, I will count. So the sentinel value here will be quit. If we enter quit, we will stop the loop. As far as we enter any name, the loop always will execute and test the next condition. So we also have something we call the nested loops. Nested loops means a loop inside another loop. And normally the way it works is that if I have a loop outside, I'll test the condition first. If the condition is true, then I'll go into the inside loop. Then the inside loop, I'm going to do something over and over and over again until the condition in the inside loop is false. Then I'll come out and come and check the outside loop again. Now, if the outside loop is false, I'll skip from the loop altogether. So if the outside loop is false, you can't go the inside loop. So again, the concept of nested loop means we have a loop inside another loop. And the outside loop is called the outer loop. So the outer loop, the loop that contains the outer loop. Then the inner loop, the loop that is contained, that's the loop inside. So anytime we are doing this, if the outer loop condition is false, we cannot even check the inner loop at all. We can't go inside. We have to come out of the whole loop. The only way we can get into the inner loop is when the outer loop condition is true. So this is an example given as the concept of a nested loop. So here we have a chapter 1 quiz, extra credit quiz. So we can see the whole concept here. We can see that one quiz is inside the other quiz, and the whole two quizzes are in chapter 1 quiz. So the flow diagram here, we have some declarations. We do some housekeeping. Our main goal is here. So here we have a quiz name, not quit. If it's not quit, then we execute detail loop function. If quiz name not quit, if we enter quit, that means it's false, so we come out. Come out of the loop. Now let's see the nested loop example here. So we can see that we have a loop. This will be our inner loop where Marquesa is. The condition is the question counter is less than or equal to questions. Then the outer loop will be the one we have part counter is less than or equal to part. Because the loop starts from the top. We know execution will start from the top of the program. So we have a detail loop. We print output quiz name. Then we initialize our loop control variable, which is called a path counter, to 1. So now we check, is the 1 less than or equal to the number of paths we have? If it's no, which means the outer loop condition is false, we cannot go inside the inner loop, as we said. So the only way we can check the inner loop is when the outer loop condition is true. If it's yes, then we are going to do something in the inner loop. After we do finish, we go back again, check the inner loop. See that we have the inner loop. We have to check, do something over and over in the inner loop until the condition is false. When the condition is false, then we come out of the inner loop and go and check the outer loop. If the outer loop condition is true, then we come back to the inner loop and do something. Then we check again the outer loop. If the outer loop is false, we cannot go the inner loop. We come out of the loop. So we can see the yes here for the outer loop means condition is true. Yes, we do something. We get rid of the inner loop. We do something. Then when we do something in our loop, we have to keep doing it until our condition becomes false before we transfer over to the outer loop. So here we say the nested loop facts. First, we say the nested loop never overlap. As we even saw, if the outer loop is true, we go inside the inner loop. We do something over and over again until the condition is false. We come out and we come and check the outer loop again. If it's true, we go back inside again. If it's false, we come out of the loop. We can't go. Anytime the outer loop condition is false, we can't go in. So here we are saying that the nested loops never overlap because an inner loop is always completely contained within an outer loop. When the inner loop to be accessed, the outer loop have to be true. And if inner loop is true, we will keep doing something in the inner loop until the condition is false. Then we come back and check the outer loop again. So it never overlaps. Also, an inner loop goes through all of its iterations, as we said earlier. If my outer loop is true and I go inside the inner loop, I have to do something, all the iterations. I have to do something over and over again until the inner loop condition is false before I will come out. Also, the total number of iterations executed by nested loop will be the number of inner loop iteration times the number of outer loop iterations. So for example, if I have a counter control loop for nested loop, and I say the outer loop will execute up to 5 times. So let's say from 0 to 4. And the inner loop also will execute, let's say 2 times from 0 to 1. The total execution will be 10. Why? Because when the condition is true and I come to the inner loop, I will execute only twice. Then I'll go back to the outer loop. And the outer loop I will execute once, then I come back to the inner loop, execute twice, go back to the outer loop, execute once, come to the inner loop twice. I will do this 5 times for the outer loop because the outer loop will execute only once. If it's true, then you go to the inner, then you execute all the inner. So if I have 2 times to the inner and 5 times outside, total will be 5 times 2. The same thing if I have 10, 10, it will be 10 times 10 because when the outer loop is 1 and it's true, it will come to the inner loop, execute all the 10. Then you go back again, check 2. So always the outer loop executes only once, but the inner loop will execute all the total iterations. So always the total execution will be the possible of both iterations for both outer and also the inner loop. Now they say we should avoid some common loop mistakes. And this is the same concept as a selection statement. Well, if I know I'm going to execute something 10 times, if I start from 0 and I end at 10, that will be 11 times. So we have to be careful with the boundary also. And also failing to initialize the loop control variable. This is a serious, that's if you have a counter control loop. You have to start somewhere. Otherwise, Again, you may have some garbage or some data already in that variable, and it may be any value, and that can change the implementation and the number of times the loop have to execute. For example, here they say we shouldn't do this because the loop control variable is not initialized. I declare variable name, and then we say quit equal to zzz. But remember, the variable string name is the loop control variable, because here we can see that name not equal to quit. So name is the variable condition, so that will be the counter. So we need to initialize. If we say name not equal to quit, what is the beginning of the name? Is the beginning of the name, let's say, go, yes, or something? So we have to initialize it. Always we need to initialize the loop control variable. Also, if we neglect to alter the loop control variable, what we have? Infinity loop. Infinity loop, because this means if I initialize it to 0 and I say 0 is less than 2, always it will be 0 less than 2 because I didn't alter the 0 no more. So either I have to increase it or decrease it so that as time goes on, the condition will be forced to stop. Also, using the wrong comparison when testing the loop control variable. So here they say programmers must be careful and must use the correct comparisons. Seriousness depends on the action performed within a loop. So overcharge insurance customer by 1 month, example, and or overbook a flight on airline application or dispense extra medication to patients. So we should be careful with the comparisons. We don't want to do something over. So we should also avoid the common loop mistakes here. This is, look what we have here. We have declaration for name. First, we didn't initialize it yet. And then we print an output statement that enter your name. This is the input for you to enter the name. Then we check if the name is greater than the quit. This is a wrong comparison. The reason is that since we have the name, for example, the name is the counter control loop or the loop control variable for the counter control loop here. And here we have the string that the quit is always z. It's always z. So doing this may give us most likely an infinity loop or something, because we have the quit a value, and the name we are going to enter can be greater than quit or may not be greater than quit. So this can cause some errors. Here we say the incorrect logic for greeting program because the wrong test is made with the loop control variable because the wrong test. Also, one mistake is including the statement inside the loop that belongs outside statement. We need to be very careful with this also. So including a statement inside the loop that belongs to outside loop. So example, discount every item by 30%, or inefficient because the same value is calculated 100 separate times for each price that is entered. So we move outside the loop for efficiency. Remember, we say the nested loop. The outside loop will execute only once. If it's true, then it will go inside the loop. Then it will execute all the possible number of times until the condition is false. Then it goes back again. That's efficient. But if you do it the opposite way, it will not work. It's not efficient. So that's the example here. I'm going to, this is also avoiding the common loop mistake, the same example, but in this case it's in a flow chart. Yeah, so next is how do you use it? So previously all the program we saw was using the while loop. While loop you can use a sentinel value, but in for loop you cannot use a sentinel value. So that's why they always call for loop as a counter control loop. We always have to know how many times the loop will execute. We can't use a sentinel value. But with while loop, we can have it as a sentinel value controlling it, or we can write a counter control while loop. We can work it that way. So we say the first statement of for loop is a definite loop. Definite loop means we know how many times the loop will execute. So it will provide three actions in one structure. We initialize, we test, and alter. So when you look at the for loop here, you can see that we initialize the counter to 0, and then we go up to 3. Step 1 means we increment by once. Then we output the program. So we have the initialization 0. We are testing that we go up to 3. 0 is less than 0 is less than 3, 1 is less than we. Step 1 means we increment by 1. So from 0, we check if it's 1 is less than 3, we increment by 1 again, 2 less than 3, we increment by 1 again, 3 less than 3, no, then we stop. So this LO will print 3 times. But this is again a counter control loop. We know how many times. We're going from 0 to 3, and the step is 1. We can write it in this form. So we start the counter from 0. We say while the count is less than or equal to 3, we output LO, we increment. So it's the same as going from 0 to 3, which again 4 times. Previously I said 3 times, sorry, it's 4 times. From 0 to 3 is 4. So because 0, 1, 2, 3 is 4. So these two loops are the same. They do the same thing. They are printing LO 4 times because 0 to 3 is 4 times. But the first one, I will not use it. I rather prefer to use the second one because all the three statement is written in one line. The count is from 0 to 3, and we move by one step. That's it, which means we increment by 1. By here, we write the count is 0. We check the condition less than or equal to 3. We output LO, then we increment it by 1. The two are the same. Again, we'll see this when we implement Java both for while loop and do while. So that's example here. If the count is 0 to 3, step by 1, which means we initialize the counter to 0, and we check if the value is less than or equal to 3. The limit value is up to 3, so less than or equal to 3. The step 1 means after each round, we increment by 1. So we say increase count by 1 using step value. So if I say step 2, it means I'll increment the counter variable by 2. So the step value again is the amount for which the loop control variable changes. So if the step is by 1, that means it changes every round, every one at a time. If the step is 2, it changes by 2, say from 1 to 3, 3 to 5, etc. So as we said earlier, well, actually we saw the two examples. We can use the while statement to replace the for statement if it's a counter control loop. We also have a loop called the do while loop. Do while loop means you do something first before you test a condition. And this is called the post-test loop. Post-test. The reason why I mentioned we have a pre-test loop here. Pre-test loop means you're going to, that's why it's called pre-test. It means you are going to test your condition before you do something. But post-test means you do something before you check your condition. So with the post-test loop, the loop will execute always at least once because you have to do something once before you check the condition. If the condition is false, that's it. But pre-test, the loop control variable is tested before each iteration. So for loop and while loop are called the pre-test loops because we saw that the conditions are checked before execution. But we also have the post-test loop. Here we say the loop control variable is tested after each iteration. And normally almost every programming language have is we call the do while loop. So here you can see the example here. Do something first. Here we are paying a bill. Do pay a bill. Then when you pay the bill finish the first time, then check why more bills remain to be paid. So if you still have more, if this condition is true, then we have to keep paying the bills. If the condition is false, we stop paying the bills. So again, this is called the post test because we have to do something first before we test our condition. A very good example here is do pay a bill while more bills remain to be paid. So our condition is more bills remain to be paid. If it's yes, then we go and pay the bill again. If it's no, we come out of the loop. Again, the do while loop is also implemented in Java language. So when we start the implementation, we may see that also. So using the post test, we may do something. This is again, the first one here is the pre-test. We can see we test a condition first. The diamond shape means we have a condition. So we test the condition first. If the condition is true, we execute. Then we come back and test the condition again. If it's true, we do our execution. But this is a post test. First, we do something before we check the condition. If it's true, then we keep doing it until the condition is false, we come out. So we should know the difference between the pre-test and post-test. Again, pre-test means test condition before execution. Post-test means we start execution first before we test the condition. So that's example using a post-test loop. We can see the flow chart here. There's a task for A. You do A finish, you check if the condition is B. If it's yes, you do A again. And here the same thing. We do something before we check condition. If it's yes, we keep doing the same thing. So again, both of them are post-test, but this is why and this is do while. But you can see that do while, the same condition we do first, we check, yes, we keep doing. We can have the first execution outside the loop. Then when we execute, then we check condition, then we do. So we can use the while loop as a post-test also, but which means the first execution will be outside the loop. This is not in the first A is not inside the loop, it's outside. But in the do while, the A is inside the loop. You can see the arrow affect it. So next is recognizing the characteristics of share by structure loop. So yeah, we said that all structure loops have these characteristics, whether it's a for loop, do while loop, or while loop. All this is shared by all the loops. So recognizing the characteristics shared by structure loops. So a loop control evaluation must provide. A loop control evaluation means the condition. The loop condition must always be provided, either to entry or exit from the structure. So whether do while for loop or while loop, always we must have the condition because that condition may stop the loop. And also the loop control evaluation provide only entry or exit from the structure. So some language support what we call the do until loop. And do until loop is supported by Visual Basic. In Java, I think Visual Basic and C Sharp, I'm not sure, but in Java, there's no do until loop. So, which is a post-test loop that iterates until the loop control evaluation is false. In Java, we don't have it, so it's not too common in many languages. The most common are the three loops: for loop, while loop, do while loop. Do until, I quite remember, it's a Visual Basic language. So here we can see the whole concept. We have a loop. First we do something, we check the loop, we do something again, then we go all over to repeat the same thing. We can have more than one execution or statement or task, more than one. So what are some of the common loop applications? We can actually, loop is used a lot in array because, for example, if I want to print all the items in array, I can have it inside a loop and I write only print statement once I need to print. The same thing if I want to enter an items in array, maybe I have to enter 10 items. I don't want to write the input statement 10 times. So I can use a loop that will give me based on the condition that we want to execute the loop 10 times, it will give me the option 10 times to enter all the values. We also use it in accumulators, summary reports. We can also use the loop for searching an item in an array, etc. So we're going to end somewhere here, and I'm going to wait for a few seconds if we have any question. Again, we're going to continue the lectures in our next class. It's almost time now. So before, most likely this video will be too large to post in the classroom. So I may post it in my YouTube channel, then I'll put the link. It should be in module 5. So because of that, I don't want to go to the school platform yet. Until, if no question, then I'm going to stop the recording, then we go to the school classroom because of, again, copyright issues. Okay, seems like no question. So again, we continue these lectures in our next class. But for now, I think I'll stop the